today I will tell you the formula related with the moving electron in the hydrogen-like atoms or ions. So these physical quantities are the radius of the orbit, velocity, linear velocity, angular velocity, and the linear momentum, angular momentum, potential energy, kinetic energy, binding energy, total energy. So all these physical quantities are associated with the electron moving in the hydrogen-like atom or ions. We have to find the answer to the multiple choice questions. So if you remember all these, then you can find the quick answer to the questions. So let us take first the radius of the orbit. Radius of orbit r is equal to 0.53 angstrom into n square upon z. Where n equal to principal quantum number, and this has the value 1, 2, 3, 4 and so on. Z atomic number, So R that is proportional to n square upon z. So as the value of n increases, this r increases, and at the value of z increases, r decreases. So this r, so as n increases and z increases, n increases, r increases. If z increases, then r decreases. So this is the relationship. This is number one. Then the linear velocity. Linear velocity of electron. Now this V is equal to 2.18 into 10 raised to the power 6 into z upon n. So from here we get this so much meter per second. This A naught, that is the angstrom. So this radius is measured in angstrom. So we have this V is proportional to z upon n. So you can see that the linear velocity of the electron decreases with the increase of n. So this as n increases, V decreases, Z increases, V increases. This is the effect of this n and z of this on this the linear velocity of the electron. This is now relation number 2. Now then we have the angular velocity. Angular velocity or angular frequency. So angular velocity and angular frequency, these are the same. So this omega, this is equal to V upon R. So now from all these we can find to this R is given here, now this is also given here, then this omega that comes out to be 4.11 into 10 raised to the power 16 into now this omega V upon R. So V is Z upon N. So this is now Z square upon NQ. This is so much. This is now relation number 3. So now what we have, now this is measured in frequency, so this is now in radian per second. So omega is proportional to Z square upon NQ. So now we can have that as Z increases, omega increases, and N increases, omega decreases. So these are the effect of this Z and N upon the angular frequency or the angular velocity. Now number 4. The linear momentum. Linear momentum. This P equal to M into V. So now we are having this P equal to 2 into 10 raised to power minus 26 into, now this is Z upon N. This is not so much. This is now 24. 24. So now this is in kilogram meter per second. Kilogram meter per second. So this is now relation number 4. So we can see that this P is proportional to Z upon N. Z upon N. So as Z increases, this linear momentum also increases. If N increases, then P decreases. Now number 5. Angular momentum. Angular momentum. L equal to N into H upon 2 pi. 1.05 into 10 raised to the power minus 34 into n. This is equal to L. This is now so much joule second. Now this is relation number 5. This is in joule second. So now we can see that this L is proportional to N. So as the principal quantum number increases, this L will increase. So we can have that as N increases, L also increases. Now number 6. Orbital frequency. Orbital frequency. F, this is equal to omega upon 2 pi. We know through this angular velocity omega, and if we calculate to this one, then we will find it 6.5 into 10 raised to the power 15. And this omega, this is now your z square upon nq. This is so much. This is in hertz, so much hertz. So we can see that this F is proportional to z square upon nq. So this F is proportional to z square upon nq. So now we can have that as z increases, the frequency also increases. If n increases, then frequency decreases. So about the frequency and the angular momentum, they are having the same relationship. This is now relation number 6. Now 7. Kinetic energy of electron. This kinetic energy is equal to 13.6 into z square upon n square. So much electron volt. This is not always positive. So this kinetic energy is proportional to z square upon n square. So what we have that as z increases, the kinetic energy of the electron increases, and as n increases, the kinetic energy of the electron decreases. Now number 8, potential energy of electron. So this potential energy equal to minus 27.2 into Z square upon N square electron volt. The potential energy is always negative. This is never positive. So this has the same potential energy is proportional to Z square upon N square. So same relationship as here for this potential energy. Now the total energy. Number 9, this is now relation number 7, this is now relation number 8. Now then total energy. Total energy of electron. So this E is equal to the kinetic energy plus potential energy, and you can see from the sum of these two that this E is equal to minus 13.6 into Z square upon N square, so much electron volt. So now we can have that this E is proportional to Z square upon N square. The total energy is always negative. So as Z increases, E increases, and Z decreases, Z, this N increases, E decreases. Now the binding energy. This is now relation number 9. Now 10, binding energy. Of electron. So binding energy is equal to 0 minus the total energy. Total energy. Total energy is negative here. This is now negative 1. So we can have that this is equal to 13.6 into Z square upon N square electron volt. This is now positive. So this is now your binding energy. So binding energy of the electron is always positive. So this binding energy is proportional to Z square upon N square. Now here we are having the negative sign, so this E increases with Z in the negative, and this or decreases with the negative. So as we goes from 0 to onwards, the value decreases, and when we come towards the 0, then this increases. And in this we are having this positive one, so this BE has the same relation as here, that this binding energy will increase with the increase of Z and it will decrease with the increase of N. So this is now relation number 10. So these are the 10 physical quantities which are related with the electron moving in the hydrogen like atoms or ions. You can find the, because I have given the numerical values along with this formula. So if you put the value of Z and N, then you can find the kinetic energy, potential energy, angular momentum, linear momentum, and etc. There's so many. So we have to just remember and memorize to all these, so that you could answer the question immediately. And always remember that these all quantities has been expressed in the, except this energy, all are in MKS system. This energy is taken in the electron volt. So this is about the different physical quantities associated with the electron moving in the hydrogen like atom or the ions. So thank you very much.